much for being here. And thank you, everybody, for um, being here with us as well. So whenever you want to start, this is your space, your presentation. Thank you so much.
Okay, great. Thank you so much for the warm intro. I am so excited to be here. I hope you guys can see my screen now.
We do, we do.
Okay, awesome. Please let me know if there's an issue. Sometimes I do have issues with Google Meets. So thanks for the wonderful introduction. I won't introduce myself anymore. So today we are going to talk about Istio Multicluster Service Mesh. And we're going to discuss some of the limitations we heard from our user on Istio Multicluster Service Mesh. And then we kind of going to explain, how we tackle this problem at Solo to solve some of the challenges with Istio Multicluster. And last not the least, hopefully I'll be able to show you a live demo if the demo guys are with me today. So today, if you go to istio.io, we support different deployment model for Istio Service Mesh Multicluster. One of the most common model is this model where you run multiple primary cluster on separate network. What does it mean by multiple primary? Multiple primary means Istio control plane, which is Istio D on this diagram, it runs in each of the clusters. So each cluster itself watches the configuration from Kubernetes. So in this requirement, because each cluster watches configuration for Kubernetes, it does require endpoint discovery from the local cluster, but also from the remote cluster. So Istio knows what are the services and their endpoints on different cluster. Also in this model, because the fact the network are different across these two clusters, we do run a gateway in between to help connect the networks, the services running on different networks. So that's essentially multi-primary Istio control plane cluster on separate network. If you just think about two cluster, it's probably straightforward for you, right? This architecture, you may not have any concern the first time you look at it, but the moment you start to think about, what if I have 100 cluster? What if I have just 4 or 5 clusters? The fact that each Istio control plane requires Kubernetes API server access, even though it's just read access, could be having security concerns. And also it's very hard to manage that configuration across 5 to 100 clusters. So this would be the architecture you would envision if you use multi-primary on multiple network that we talked about earlier on a much bigger scale from 5 cluster to 100 cluster. So the concerns we've been heard is it's very hard to sync and store all the Kubernetes API server credentials using traditional GitHub flows, right? Which we recommend people to use when they deploy Istio resources, when they deploy Kubernetes applications. GitOps is the recommended way we want everyone to use, so you can recreate that easily across different environments. The other concern we also heard is giving a cluster just read access to many other clusters could leave a security threat. It's unnecessary to give out credential to all of your cluster, to each of the Istio control plane. So in Gloo Mesh, what we invented is a different model to specifically solve the concerns we heard from our user. In this model, we're proposing Gloo Mesh as a central management plane And then inside of each of the Istio cluster, we would run a Gloo Mesh agent that communicate to the Gloo Mesh. So there are two challenges we're trying to solve. So first of the challenging is Gloo Mesh as a management plane needs to have the configuration. It provides an abstraction configuration on top of Istio. It's more opinionated to help users simplify their adoption of Istio. And we need to be able to propagate that configuration to each of the Istio cluster in the language that Istio can understand. The second challenge we're trying to also solve is each of the Istio cluster, I mean, they're not going to be stale, right? As services gets deployed, as services get scaled in and out, the services and their endpoints could be changing. So who is going to reflect those changes to other clusters? This is essentially the job Gloo Mesh agent is doing. It's propagate those configuration service discovery changes back to the management plane. So the management plane have all that information. So this would save the user from giving Kubernetes API server access to each of the Istio control plane. So what we are proposing, which is also implemented in Gloo Mesh, is a pool-based configuration model that I just described. It's using a centralized management plane that doesn't require any access to any of the data plane cluster. It doesn't require any access to remote Kubernetes API server. It doesn't require any of the API server credential on any of the Istio clusters. So the data plane cluster connects to the central management plane cluster and receive the configuration update. We really like the XDS protocol from Envoy, which is essentially what Istio uses to push the configuration from Istio control plane to the Envoy sidecar. So we're reusing this configuration model in this architecture also. And we talk about credential no longer needs to be shared, which was the fundamental problem we're trying to solve. So in order for each of the Istio cluster to register with the management plane, all it needs to do is call meshctl cluster registration and specify, this is the management cluster context, this is the remote cluster context, and this is the relay server address. So the relay server is the management server that provides the gRPC service. So it needs to make sure it knows that endpoint. So how does this work? We talk about it's inspired by the XDS protocol and also using Kubernetes Bootstrap token to establish the initial certificate and keys required to establish the mutual TLS configuration between the Istio cluster to the management cluster. So let's look at the two components we're describing. So on the left side, the enterprise networking is the components on the management plane running on Gloo Mesh management plane. And the agent on the right side is, think about it, it's the Istio cluster where we have the agent, Gloo Mesh agent running. So at the installation time, we're going to distribute the root search to the agent along with, the location, the address of the enterprise networking, which I showed you on the meshctl registration command. And then the Bootstrap token will also be mounted to the agent pod, so the agent can have access to the Bootstrap token. The agent is going to make the initial request with the Bootstrap token. So that's going to be a TLS request to the enterprise agent. And the enterprise agent would respond with the client certificate, which you see on the right side. so that it can allow the agent to establish mutual TLS communication with the enterprise networking component from Gloo Mesh. With that, the agent can establish the remote resource gRPC stream so that if there's any configuration changes, it can, if there's an endpoint changes, it can surface those changes to the enterprise networking component. Also, in the meanwhile, the agent is going to also open a mesh config stream, which is also a gRPC stream. This is for the purpose if the user deploy any Gloo Mesh customer resources, and the enterprise agent needs to push those translated Istio resources back to the Istio cluster, it can push that configuration through the agent so that the Istio translated resources would be available on the Istio cluster for the user. So can this model really solve our problem? I would say yes, most likely. For two of the concerns we talked about earlier, right? So first, the concern we talk about is giving the Kubernetes API server access to each of the Istio cluster in a multi-cluster environment. So in this model, there's no API server credential needed to be configured. The second problem we talk about is for the GitOps workflow, right? Having that credential, where are you going to store that credential in GitHub? So by eliminate the API server access credential, eliminate the configuration complexity with the GitHub flow. Now it's the demo time. Any questions so far?
Yeah. So if you go back a couple of slides.
This
yeah,
one?
okay. In this case, yes. So you said respond with MTLS cert. You also need to send the private key that goes with the cert, right?
Yeah, so we send the client certificate goes with the cert for sure. I would imagine the private key would also be part of it because it needs to, but I do have to double check because it needs to be, so we send the minimum required to establish the mutual TLS communication.
Okay, so you don't know whether the private key stays with the agent or is it actually also sent by the left-hand box to the agent?
So is the private key absolutely necessary for establish the mutual TLS cert?
Yes.
Okay, so if the private key is necessary, well, so first of all, right, so it's a signing problem, right? So you could potentially have the private key at the initial bootstrap time, and then you just assign the key. I think that's most likely what happens here, so that you don't have to transit the private key on the wire. I think that's your concern. Is that right?
Right. Yes.
Yeah, I think this model actually is very much what we do in Istio, right? Because Istio has the same problem from the Envoy proxy to Istio control plane. So we essentially reuse the same techniques and establish the secure communication from the agent to the enterprise networking here.
Okay, thanks.
Any other questions? Okay, great. So I would like to show you guys a global failover demo with multi-clusters, right? So we have 3 clusters in this environment. The first cluster, you can see it has the Istio booking for application. The only thing is we don't run review version 3. It's only on the second cluster. And the reason I do that is it's really for you to easily to see the global failover. I mean, you could potentially run review version 1 and 2 on the second cluster, but it's not easy for you to see because they look the same. So cluster 1 and cluster 2 have Istio running on Kubernetes. They both have ingress gateway because they're not using flat network in between, And also I have Gloo Mesh management plane on a separate cluster also running in Kubernetes. So what we're going to do in the demo is we're going to trigger a failover scenario. So we're going to fail over the reviews on the first cluster, and then we're going to see how the traffic handling, right? So if you don't do anything, obviously nothing is going to work, right? So if you don't config like your global destination for the review, so there's no traffic failover, nothing is going to work. But then we're going to show you how you config this to leverage this concept of virtual destination so that it would fail over seamlessly to the remote cluster, which is cluster 2 here. Okay, so in my environment, if I refresh Bookinfo right now, I have, it's going to be going to the first cluster because I didn't config anything special, right? So I didn't config the traffic flow allow product page to go to version 3 of the review. So everything is just local. As you can see, it's toggle between 1 and 2. And this is my Gloo Mesh environment. By the way, let me make sure you can see the graph here too. So we do have a graph where you can easily see, well, I have 2 clusters I was mentioning to you exactly as this diagram, right? So I have review version 1 and review version 2 in the first cluster, and there's no traffic to review version 3 because I haven't configured anything yet. So in my cluster, if you go to like the meshes, you can notice I have 2 cluster, cluster 1 and cluster 2. And I have, if you view the mesh details, you know, you can see all my workloads and everything. So this UI just shows you different configuration, what are the clusters, you know, what are your, each of the cluster has Istio D, and you know, what are your gateways, which each of the cluster has gateway, right? So pretty much match the diagram I was just describing to you of my environments. So what we're going to do next is we're going to trigger some traffic. So this is the diagram I was showing you earlier. So we're going to be on this page. So if you go to last 1 minute, this is the one, you shouldn't see any reviews because I was prepping, which is why if you go to last 15, you might see, because I was demo before, before this meeting. All right, so are you guys with me? So all the traffic is on review version 1 and version 2, which is on the cluster 1. So what we're going to do next is, let me clear out my screen here. So what we're going to do next is we're going to disable reviews on cluster 1 and cluster 2, just to trigger a failover scenario. So when those are disabled, what do you think is going to happen, right? So if your service is going down, right, this is what you expect, right? You won't be able to have the review service for the book. So this is expected, right? So what we're going to do next is to show you what you should have it before, you know, your service went down. And in fact, on the left side, you can see the service went down through our observability UI also, right? So what we're going to do is applying a resources called virtual destination. The reason we do this is virtual destination is a Gloo Mesh concept to provide a global destination regardless where your actual service runs, right? It could be running on VMs, it could be running on cluster 1, cluster 2 in different clouds or in different zones and regions. But we bring it together with this host name. You could call it reviews.yourcompany or reviews.global. It's just an example here. And the other thing we're going to need to do is apply a traffic policy to say, you know, for the reviews, we want to do when it's accessing from the default namespace, which is the product page runs. When it's trying to access reviews, you know, we want to send to this virtual destination, which we just deploy, right? Because I don't care about if the reviews is on local. All I care about is availability, right? When the local is failing into my outlier detection, I want to detect it and goes to the global, whichever the global is. So in this case, it's a cluster 2, right? So now if we go back to the product page, I would expect review version 3, and I would expect only the version 3 because the reviews version 1 and 2 are done. So what do you think is going to happen if I bring the reviews back on the first class? By the way, you can see the graphics also render, right? So this is shifting all the traffic to the reviews version 3. So what we're going to do next is actually make review version 1 and 2 available. So assuming, you know, your service went down for maybe a minute or two, right? And if you have virtual destination and traffic policy, your user will be seamlessly, right? So now that we bring the service back up, let me see if the service are up. Sometimes it does take a little while. So if you do get cluster 1, you should be able to see them. So you can see they are terminating, but they also come up. So it's good. So the reviews, actually the reviews 1 are terminating. The reviews 2, okay, it's also running. It's also running. Sorry, it was my share screen was hiding that. Okay, so now if I hit the refresh, what do you think is going to happen? So I do think it's going to hit review version 2, which is good. I also think it's going to hit review version 1, which is also very good. Do you think it's going to hit review version 3? The answer is no. As long as you review version 1 and 2 are healthy. The reason is when we apply the traffic virtual destination, we actually said we prefer local. And if local fails, you know, and these are my outlier detection criteria, and it fails, we want to fail over to the global virtual destination. So if local is running, you know, we want to always goes to local. Why? Because local has low latency, right? Who wouldn't wants to have low latency and pay less network money for this. So as you can see on the left side, you know, the reviews are not going to version 3 at all, right? Which is exactly what we are seeing. So as you can see, through virtual destination and traffic policy, you know, we seamlessly transition for a global failover scenario for the user. But also, this is just one thing, but we are a gRPC community, right? So I want to talk to you some of the challenges we're going through with this, right? So remember I talked about early on the Gloo Mesh resources, right? So the Gloo Mesh resources, once the user apply them, how it ends up to the resources that Istio can understand, right? Because Gloo Mesh is not reinventing the wheel, we're still reusing resources from Istio. So this is the work that's been done by the Gloo Mesh management plane, and the management plane pushes the configuration to the Gloo Mesh agent as this diagram indicated, right? So the mesh configuration are pushed back to the agent, and then it gets onto the Istio cluster, right? So the Istio has the configuration. So let's look at the configurations on our Istio cluster. So we have 2 clusters here. This is the first cluster. So for instance, if you are familiar with Istio, service entry is the key resources that helps you connect services on the remote cluster. And destination rule is the key resources that can fix like outlier detections. So so we would expect, let's say, service entry, for instance. I would expect the service entry for the review cluster, for instance, on the cluster 2. So let's see, this is the reviews global. So you can see how the reviews global are configured. And interestingly, this is the ingress gateway on my EKS cluster, which is on the second cluster, which runs the review versions 3. So that's how, you know, we build this reviews global service entry for you automatically behind the scene without you needing to do anything. And we also build let's see, I'm expecting reviews ratings, let's see. Okay, I'm expecting this one. Yeah, reviews.default. So this one also helps you to connect the endpoint, right? So this is our VIP for that service entry, and also the service entry is for the reviews.default.cluster2.global, and this points to the ELB on my EKS cluster and for this particular host name. And then we also have a little bit of magic on the cluster 2. We also have service entry on cluster 2 that helps you to map, hey, for this reviews.global, you know, how we are going to actually map to the actual pod on the cluster 2. So if you look at the reviews that cluster.global, this is actually the pod IP for the reviews version 3 on the cluster 2. So by the way, the reason I highlight the IP here is this is another magic done by Gloo Mesh, because the IP address can change, right? As the reviews 3 gets scaled up and down as you become more than one replica, or maybe the IP address could change because of the recovery of the pod. So this needs to be dynamic discovered by the Gloo Mesh agent on the local Istio cluster, which is the cluster 2, and then also pass that information to the Gloo Mesh management plane. So Gloo Mesh management plane could generate the correct service entry. So a lot of hand-holding, a lot of automation in place from that gRPC you know, stream from the agent to the management plane, and which enables this type of global service failover scenario that you are seeing. So that's it for my demo. If you guys have any questions, let me know.